Hello everyone. This video I have made to describe mechanism of action of cardiac glycosides. Okay, cardiac glycosides are drugs which are positive inotropic drugs used in heart failure. Now, basically, what happens in heart failure? There are two types of heart failure, that is systolic and diastolic. In systolic type of heart failure, the heart is not able to pump enough amount of blood required for the body, right? So what happens is the cardiac output or ejection fraction decreases below the requirement of our body. Okay, so for treating the heart failure, we use various spectrum of drugs, and cardiac glycoside is one of them. Cardiac glycosides are group of drugs which basically only provide symptomatic relief. They don't actually help in decreasing the pathophysiology, but they improve the contractility of myocardium. Now, basically, what happens is by the cardiac glycosides, the force of contraction increases, right? And we all know that as the force of contraction increases, the cardiac output increases, and that's what we want in heart failure, right? Now we have various various drugs included under cardiac glycosides, like Digoxin, Digitoxin, Obane, but at present only one drug is used clinically, and that is Digoxin. Okay, so Digoxin is used clinically nowadays. Okay, now we'll see mechanism of action. Okay, now first I'll show you what happens normally during the cardiac cycle, right? Now, during depolarization, now we all know that depolarization means the membrane potential going towards less negative value, right? And when that occurs, the voltage sensitive L-type calcium channels open. Okay, so we see here that as soon as the action potential arrives here, the voltage sensitive L-type of calcium channels open. Now this is the membrane, this is the intracellular part of a cardiac muscle fiber, and this is the extracellular part. Okay, so as soon as the action potential arrives, the voltage sensitive L-type of calcium channel opens. Okay, and the calcium comes in, the calcium enters inside the cell. Okay, now this is the trigger calcium. Okay, now this trigger calcium will stimulate the ryanodine receptor of the sarcoplasmic reticulum. Now inside the cell we have sarcoplasmic reticulum, that is endoplasmic reticulum of cardiac muscle fiber. Okay, now this sarcoplasmic reticulum is full of calcium. It has abundant amounts of calcium, and this small amount of calcium that has entered from outside is going to stimulate the ryanodine receptor, and large amount of calcium would be released from sarcoplasmic reticulum to the inside of the cell. Now we all know that calcium is required for the breaking of active myosin complex and for causing contraction, right? For the formation of actin myosin complex and for contraction, right? So these calcium will cause contraction. Okay, now for relaxation, what is going to happen? We'll see that. Okay, now for relaxation, we see here that this calcium has to somehow go from has to move out of this cytoplasm. Okay, or else it is going to continuously form this in actin myosin complex, and the muscle will continuously contract, right? But it has to go inside. So what happens is this SERCA2 is going to pump all this calcium back into the sarcoplasmic reticulum. Okay, this SERCA2 is going to cause all the calcium back into the sarcoplasmic reticulum. Okay, we have this protein calciquestrine, which is going to store the which forms complex with the calcium. Okay, now remaining small amount of calcium moves out of the cell by NCX antiporter in exchange of sodium. 3 sodium comes in. Okay, so a major amount of calcium goes into the sarcoplasmic reticulum and a small amount of calcium goes out by NCX antiporter in exchange of 3 sodium. That is 3 sodium comes in. Okay, now this calcium has to go inside this or has to go outside for relaxation to occur. Okay, and in exchange 3 sodium has came in. Okay, now this 3 sodium that has just entered will move out and 2 potassium will come in. Okay, 3 sodium will move out and 2 potassium will come in by sodium potassium ATPase pump. Okay, so this is the whole cycle. The calcium has moved out and moved into back into the sarcoplasmic reticulum, so it is not present in the cytoplasm now, so relaxation occurs. Okay, so this is how normally the cardiac cycle goes on in the myocardium. Okay, so now what happens is digoxin acts here. Digoxin inhibits the sodium potassium ATPase pump. Now imagine that this pump is inhibited, so what happens is potassium doesn't move in, sodium doesn't move out. Now what is this going to cause? There is going to be slow accumulation of sodium inside the cell, because this is not working, so sodium is not moving out, so sodium is going to accumulate. Now this sodium is going to rise slowly and slowly inside the cell. Now this sodium is rising, so sodium outside will not be able to come inside because gradient is not maintained. The sodium inside is rising, and that's why the outside sodium won't be able to come inside. Now this sodium is not able to enter, so calcium is not going to be able to move out. So ultimately, after all that, the calcium is going to get accumulated in the cell. Okay, now slowly what the cell will do is it will pump the calcium into the sarcoplasmic reticulum. So after every cycle, large and large amount of calcium will be able to accumulate inside the cell. Now calcium, we know that calcium is responsible for the contraction, so more calcium means more activation of more number of actin myosin complex and more forceful contraction. So this is how it basically works. Digoxin inhibits this. So what will happen is sodium is not going to be able to move out. Sodium is going to accumulate, gradient is not maintained, and that's why sodium is not able to come inside, and that's why this pump is also not working much, and that's why calcium is also not going out. So calcium slowly accumulates in the cytoplasm as well as in the sarcoplasmic reticulum, and that's why after every contraction there will be more release of calcium from sarcoplasmic reticulum, and that's why the force of contraction will be more after every cycle.